In the previous video, the main concept was adding and subtracting polynomials with parentheses. The main focus of this video will be multiplying algebraic expressions and using the distributive property. In an earlier module, I talked about using the distributive property to solve various problems. I want to start by reviewing some of those ideas, which will then lead us into multiplying algebraic expressions. If you are multiplying together 4 times 32, one way you could do it is just use the traditional algorithm and multiply 4 times 32 the way that you may have done it back in elementary school. However, we could also do it by using the distributive property. And we could think of that 32 as 30 plus 2. So it's really 4 times, I'm going to put a little dot there to signify the times. It really is 4 times 30, which is 120, plus 4 times 2, which is equal to 8. So we get an answer of 128. This is the distributive property of multiplication over addition. When multiplying with algebraic expressions, I have to use the distributive property because I don't know what a plus 5 is equal to. Now, there is an understood multiplication sign between the 4 and the set of parentheses. I'm going to put a little dot there. Normally we would not do that, but I just want to make sure you realize that this is multiplication. But I'm going to do the same thing. I'm going to multiply 4 times a, and I get 4a. I'm going to multiply 4 times 5, so I get 20. So, if I use multiplication, I will just get an answer of 4a plus 20. And since those are not similar terms, I can't do anything else with it. Here's a little bit longer example, and I want to go through and I want to simplify this algebraic expression. First of all, I'm going to have to go through and use the distributive property because I want to distribute this 2 right here with the a minus 5. So it would be 2 times a, or 2a, subtract 2 times 5 is 10. And then, remember, I'm going to keep this subtraction sign the same. I'm going to keep the a the same and the 4 the same in the second set of parentheses. But I'm going to take the opposite of the sign that is in here in the operation. I'm going to change that from addition to subtraction. So now I have 2a subtract 10 subtract a minus 4. Now I'm going to go through and I'm going to combine my like terms that I have. So I have 2a subtract a is equal to 1a, which I'm just going to write as a. And I have a subtract 10 subtract 4 more, which would give me a subtract 14 for my final answer. Sometimes you might have to use the distributive property twice. And here's an example. First of all, I have to distribute this 4 with the a and the 2, so I'm going to multiply 4 times a, and then 4 times 2, and it's a subtract, so I get 4a subtract 8. Now I need to distribute the 5 with the a and the 5 with the 4. But remember, with this subtraction sign here, the subtraction sign stays the same. The first number stays the same. In this case, it would be 5a. Now I'm going to multiply the 5 times the 4, and I get 20. But because of the subtraction sign, this operation is going to go to its opposite. It's going to become plus 20. So now I have 4a subtract 8 subtract 5a plus 20. And I'm going to go through and I'm going to combine my like terms. I have 4a subtract 5a, which gives me a negative 1a, which I'm just going to write as negative a. I have negative 8 is the way I need to think about that, plus 20, which gives me plus 12. So the answer to this is negative a plus 12. Once again, one of the most common mistakes I see is when there is a subtraction sign in front of the parentheses, and it doesn't matter if you're then using the distributive property or not, the rules are still going to be staying the same. There will be times then you are multiplying 2 sets of polynomials together, for instance in this example. So in this example I have a plus 2 times, in parentheses, a plus 3. I want to use the distributive property. So once again I'm going to have to multiply a times a a times a is a squared, but I also need to multiply the a times the 3, which is equal to 3a. Then I need to multiply the 2 times everything that's inside that second set, so I get 2 times a is plus 2a, and then I need to multiply the 2 times the 3 as well, and I get 6. I can combine some like terms. I can combine the 3a plus the 2a. The one thing I cannot do is I cannot do anything with this a squared. I can't combine that with anything. A squared is not the same as just an a term. So I end up with a squared plus 5a plus 6. Depending on the problem, sometimes doing all this multiplication, see all these red lines I have drawn here, can get a little bit confusing. So there is an easier way. There's an acronym that we use called FOIL. And FOIL is an easy way of multiplying when you have polynomials. FOIL stands for first, outer, inner, last. And let me go through the FOIL method with another problem. So I'm going to use the FOIL method for figuring out the answer to x plus 4 times x plus 3. First of all, I'm going to take the first 2 terms in each one of the polynomials. I'm going to multiply them together. X times x is x squared. Then I'm going to take the outer 2 terms, the 3 and the x. I'm going to multiply them together, and I'm going to get plus 3x. Then I'm going to take the inner 2 terms, the 4 and the x. I'm going to multiply them together and get plus 4x. And then finally, I'm going to be taking the last 2 terms, the 4 and the 3, and I'm going to be multiplying them together, and I'm going to be getting plus 12. Then I can go through and just combine what I have. The 3x plus the 4x can be combined. I get a final answer of x squared plus 7x plus 12. The FOIL method is just a nice, easy way of making sure that you're multiplying everything that you need to be multiplying to come up with the correct answer. Here's another example that I have. 2a subtract 5 times 3a plus 6. The first thing I'm going to do is multiply the first 2 terms together. So 2a times 3a is equal to 6a squared. Then I'm going to go through and I'm going to multiply the last 2 terms, the 2a and the 6, which is equal to plus 12a. Then the inner 2 terms, the 5 and the 3a. But that 5 needs to be thought of as a negative 5 because of the operation in front of it. So it's really minus 15a. And then the last 2 terms, the 5 and the 6, but once again that 5 needs to be thought of as a negative 5, so I get subtract 30. Now I can go through and combine the 12a minus 15a, so my final answer is 6a squared minus 3a minus 30. Sometimes it helps to have a visual representation of this. So let's say I had a rectangle, and the length of the rectangle is x plus 9, because this distance right here is the x, and this distance from here to here is 9. The width of this is x plus 4, because this distance is x, and this distance here is 4. If I wanted to find the area of this, really what I'm doing then is I am multiplying x plus 9 times x plus 4. Well, I could really break this down too and just find the area of this area right here. The area of this is x times x, which is x squared, which is the same thing I get when I multiply the first 2 terms. X times x is equal to x squared. The area of this area right here is x times 4, or 4x, which once again is the same thing I get when I multiply the outer 2 terms. 4 times x, I get 4x. This area right here would be 9 times x, which if I multiply the 2 inner terms, I get 9x. And this area right here is 4 times 9. 4 times 9 is 36. And once again, it's the same thing I get when I multiply together the last two terms. So I have x squared plus 4x plus 9x. I can combine those. I get x squared plus 13x plus 36, which is exactly what the area of that entire rectangle would be if I added all those parts together. Finally, I want to talk about a common mistake that I see. Let's say you were given x plus 5, that's in parentheses, and the whole thing is squared. That means that I need x plus 5 times x plus 5. And some people take a look at this and say, well, that answer would be x squared plus 5 squared would give me 25. But that's not going to be the correct answer. Because really, what x plus 5 squared means is x plus 5 times another x plus 5. So now I need to go through that FOIL process. X times x is x squared. Then the outer 5 and the x gives me plus 5x. Then the inner 5 and the x gives me another 5x. And then the last 5 times 5 gives me 25. So the real answer to this is x squared plus, combining the 5x and the 5x, I get 10x plus 25. This is just something that I commonly see, which is not true. So please be cautious of that. So let me give you a couple of problems to do on your own. If you would copy them down and do them and then start this back up again, that would be great. Okay, as I go through and do these, I'm going to use the FOIL method for both of them. So first I'm going to multiply the x and the x, I'll get x squared. Then I'm going to multiply the outer, this is a 5 and an x, but there's a subtraction sign here, so I need to put subtract 5x. Then I'm going to do the inner, the 3 and the x, and that's plus 3x. And then I'm going to do the last. I have a 3 times a 5, but once again with the subtraction sign there, I need to think about that as a negative, so I get subtract 15. I can go through and combine my x's, so my final answer is x squared, subtract 2x minus 15 for the final answer. The second problem gets just a little bit more complicated, but it works exactly the same way. First thing I'm going to do is multiply the 2x times the negative 3x, which gives me a negative 6x squared. Then the outer, I have the 2x times the 4, which gives me an 8x. But because there is a subtraction sign here, I need to think of that as minus 8x. Then I'm going to do the inner two terms, and this is a negative 7 times a negative 3x. A negative times a negative gives me a positive, so it's plus 21x. And then the last two terms, I have a 7 and a 4, but they're both considered to be negatives. Once again, negative times a negative gives me a positive, so it's equal to plus 28. Then I can go through and I can combine these two terms, so I end up for a final answer of negative 6x squared plus 13x plus 28. I will tell you that this is an area that in the past some people have struggled with. Not only do you need to keep the rules of FOIL together, you also need to remember the rules of adding and subtracting positive and negative numbers, which does make it a little bit more difficult. If there's anything I can do to help, please let me know. At the end of the first video in this module, I asked you to complete a quick check to gauge your understanding of the concepts, and I would like you to do that again. If you do well in the quick check, you may be ready to take the quiz on this module. As always, there are additional resources you can find in this module that will give you additional explanations and practice as well. Thank you.